Hello, this is second day and second lecture of second chapter, that is nothing but the electrostatic potential and capacitance. And in the first step lecture we have studied about the electrostatic potential difference and electrostatic potential. Electrostatic potential is the work done in displacing a unit positive test charge particle from one point to another point in electrostatic field against electric force is called the electric potential difference between the points, means VB minus VA is equal to WAB upon Q0. If Q0 charge particle is displaced from A to B, then VB minus VA means potential at the B point and potential at the A point, the difference is equal to the work done in displacing the charge particle from A to B against electrostatic force is called the electric potential difference. If the point A is displaced or outside the electric field and the charge particle is brought from infinite to certain point B in the electric field, then the potential at A point will be 0, and this is VB. So VB minus 0 is equal to again WAB upon Q0, or VB is equal to WAB upon Q0. So work done in displacing a unit positive test charge particle from one point to another point in electrostatic field against electric force is the electrostatic potential difference between the points. And the work done in displacing the unit positive test charge particle from outside the electric field means from infinite to a certain point in an electric field is the work done in displacing a unit positive test charge particle from infinite to certain point in electric field is the electric potential at the point in electric field. Their SI unit is volt, and this is joule per coulomb, and since the work done and charge both are scalar quantities, so joule per coulomb means volt, or potential is also a scalar quantity, and joule per coulomb is the volt. And what is 1 volt? We have discussed also. When 1 joule work is done in displacing a unit positive test charge particle from one point to another point against electrostatic force, then the potential difference between the point is called 1 volt. And if 1 joule work is done in displacing a unit positive test charge particle from infinite to certain point in electric field is the then the potential at the point is called 1 volt. So this is the value of 1 volt. The dimensional equation also we have discussed, M1 L3 P minus 3 M minus 3. So this is the electrostatic potential, its SI unit, its formula, and all this. Now we shall today we shall discuss about the work done due to a point charge or electrostatic potential due to a point charge. Electrostatic potential due to a point charge. Electrostatic potential due to a point charge. So electrostatic potential due to a point charge, we consider a point charge Q at point O and a distance r, we consider a point P where we want to calculate the electrostatic potential. And for the purpose, we have to calculate, because we have to calculate the electrostatic potential at a point, so we have to bring a unit positive test charge particle from infinite to certain point. So we consider a positive unit test charge particle or positive test charge particle is brought from infinite to P point. And then we have to calculate the work done against electrostatic force, that is nothing but the Coulomb force. So the work done in displacing a positive test charge particle Q0 from infinite to this point, so work done will be is equal to W is equal to integral infinite to certain distance r F dot dr. W is equal to infinite to r F dot dr or F dr. So W is equal to integral infinite to r K Q Q0 upon r square. This is the electric force or Coulomb force, and dr. So W is equal to K Q Q0 can be taken out because it is constant, and then integral infinite to r power minus 2 dr, and then W is equal to K Q Q0. The integration of r power minus 2 is r minus 2 plus 1 upon minus 2 plus 1 infinite to r, because integral x and dx, this is the formula for integration x n plus 1 upon n plus 1. Here n is equal to minus 2. So we consider r is r power minus 2 plus 1 upon minus 2 plus 1 according to this formula, and W is equal to we obtained KQQ0 r power minus 1 upon minus 1 infinite to r, or W is equal to KQQ0 minus 1 upon r infinite to r. So W is equal to minus KQQ0 1 upon r minus 1 upon infinite, or W is equal to, or W upon K0 is Q0 is equal to minus KQ upon r. We know that the work done is against the electrostatic force, so it should be negative. So minus W upon Q0 is equal to KQ upon R, and this is nothing but the potential. So V is equal to KQ upon R. So this is the formula for a potential due to a point charge. Again I am explaining work done in displacing a positive test charge particle Q0 from infinite to R can be taken as W is equal to integral infinite to R F dot dr, and F dot dr then KQ0 upon R square dr, or W is equal to KQ0 R power minus 2 dr, and this is the minus 1 upon R, because here the work done is against the displacement of the particle. So we consider the minus negative, and minus W upon Q0 will be is equal to the potential, and this is the potential due to a point charge. And here KQ, so V is equal to KQ into 1 upon R. This is the formula of Y is equal to M into X, means a straight line. So potential due to a potential between the variation of potential with the separation or distance of charge will be is the hyperbolic V and R will be the hyperbolic shape, and if we want to determine or we draw the curve between V and 1 upon R will be a straight line passing through the origin. So this is the electrostatic potential due to a point charge. W is equal to, and V is equal to, V and R is hyperbolic, and the shape of the curve will be, and the variation between V and 1 upon R will be a straight line passing through the origin, because here is V is equal to KQ into 1 upon R, or Y is equal to MX. So V and 1 upon R, a straight line is obtained, and again the slope of curve will be is equal to KQ. The value of K is 1 upon 4 pi epsilon into Q, and the slope of curve will depends upon this K and magnitude of charge. For the greater magnitude of charge, the slope of curve will be greater, and for smaller magnitude of charge, the slope of curve will be smaller. And we can draw the curve just like that. If V is here, 1 upon R is here, and two curves are obtained, one for Q1 and other one is for Q2. We know that the slope for the Q1 is greater than Q2, so the magnitude of Q1 will also be greater than the Q2. Slope of curve due to slope of curve for the charge Q1 and Q2, K is constant for the both the conditions. Then in this case the magnitude of charge will be greater than that of the charge Q1 is greater than that of the charge Q2. And for the vacuum, if we consider two curves of V and 1 upon R, and again there are two curves are obtained for same magnitude of charge, one for vacuum and other one for medium, then we know that this is the value for 1 upon 4 pi epsilon, and this is the value for 1 upon 4 pi epsilon. This is for vacuum epsilon, and this is for 1 upon 4 pi epsilon naught epsilon r, means K0 upon epsilon r, means here it is for K0. For vacuum the slope of curve will be greater, and for a medium the slope of curve is smaller. So there are the two conditions, because the slope of curve y is equal to mx. In this condition the slope of curve will be is equal to kq. For vacuum the magnitude of k is greater, and for a medium the magnitude of k is smaller. So the slope for the medium will be smaller than the slope for the vacuum. So here it is the greater slope is contained by the magnitude vacuum medium, and this is for any other medium. So here it is the conditions. And for the charges, for the case of charge, the greater charge shows the greater slope of curve, and the smaller charge shows the smaller shape of the curve. So this is the electrostatic potential due to a point charge. The formula is V is equal to KQ upon R, means V is inversely proportional to R, and V is inversely proportional to R means the curve between V and R is hyperbolic shape. Is hyperbolic, and for V and 1 upon R, the slope of curve, the shape of the curve will be a straight line passing through the center, and then we consider two separate points, because the slope of curve depends upon the value of k and q. For the greater value of q, the slope of curve will be greater, and for smaller value of q, the slope of curve is smaller. And for the case of k, for vacuum the slope will be greater, and for a medium the slope of curve will be smaller, because the relative permittivity for a medium never be less than 1. any medium. For water it is near about 80, and for mica it is near about 6, and different mediums have the different relative permittivity, and this is the value of relative permittivity. Now we shall discuss a new topic, that is the equipotential surface. What is that? Equipotential surface. We know that equi means equal, potential means potential, surface means surface. Means a surface that has potential equal at all of its points. A surface that has equal potential at all of its point is called the equipotential surface. Just we consider a point charge here, and due to this point charge, the equipotential surface will be this, because due to this point charge Q, the value of potential at a certain distance is kq upon r, and we know that the magnitude for a single charge, the magnitude will be is equal to this. So the shape of the curve will be, equipotential surface will be spherical for a point charge in a space. So here it is the equipotential surface. Equipotential surface. In this equipotential surface, if we consider a particular equipotential surface, then we consider any two points A and B. Since the potentials are same, so VA and VB are the potential, then VB minus VA will always be equal to 0. Because the potential is same, so potential difference between the 2 points is always equal to 0, and we also know that VB minus VA is equal to WAB upon Q0, means work done will also be equal to 0 for a equipotential surface. So the potential difference between any 2 points of equipotential surface will be 0, and also any kind of charge, any magnitude charge, any charge magnitude when displaced from one point to another point, then the work done will be 0. Work done between any 2 points displaced from one point to another point on an equipotential surface will also be equal to 0. And this question is frequently asked in the CBSE board examination, so we must know that the work done in displacing any point charge from one point to another point will be 0, because the potential difference will also be 0 for an equipotential surface in case. And also we know that the work done is 0. We know that W is equal to F dot dr, or displacement. So this is the displacement from this point to this point. In this case, let us consider. And F is what? F is the electric force. And electric force for unit positive test charge particle, we know that F is equal to KQ0 upon R square, or F upon Q0 is equal to KQ upon R square, and this is nothing but the electric field intensity, and electric field intensity will has the direction along the direction of force, and electric line of forces shows the direction of electric field intensity, or electric field intensity. So the direction of electric line of forces will always be perpendicular to the force. Will be perpendicular to the equipotential surface. again I am explaining, we know that the work done will be 0. Work done will be 0 means F dot dr will be 0 and F dot dr will be 0. There are only three cases. Number first, the displacement 0, which is not 0 we have considered. In this case, the force be 0. No. Then the only one case, and that is what? F dr cos 90. Only in this case, the work done will be 0. And for this case, means F and dr must be perpendicular. And force is what? Force is the direction of electric line of forces, shows the direction of force experienced by the charged particle, means the electric line of forces are always perpendicular to the equipotential surface. Again telling to you, the direction of electric line of forces is always perpendicular to the electrostatic force. Electrostatic force. So here it is the value, again I am explaining. What is electrostatic, the electric line of forces? We know that the work done is 0 in this case, FdR is 0. If this is only possible when FdR is equal to cos 90, and it is only 0 when the force and displacement are perpendicular to one another. And here the case F is equal to Q0 upon R square, means electric field intensity. So the electric line of forces will show the direction of force, and this displacement is on the equipotential surface. So electric line of forces are always perpendicular to the equipotential surface.